Okay, so here's an exercise for you, and we are gonna try to cluster the fish again. So we are using the same data set. Oops, we are in the same data set, and well, you want to use the SSE again to evaluate the clustering results. And in this case, well, we want to forget that K is the best. There are a total of K different species of the fish, and then we want to use our way to determine what is the best K value for this data set. Okay, so well, you can make use of the Euclidean distance, and after that, and you also need to use this K-means SSE. And for this K-means SSE function, well, you have already seen Maverden, and for this part, you do have to make a small modification, just a small modification. Okay, and after that, we don't know what is the right K value, so we want to try different k values from 1 to 39, and then for each of the k value we want to keep a record of the SSE. So finally we want to make a plot, so we just plot the drop of the SSE, and then we'll based on the drop of the SSE, and then go ahead and try to decide which is the best k value. So um, based on my observation, it seems that I'm gonna pick a 5 here because, well, before 5, every time we increase the k by 1, and then there is a good job of the SSE. And then after 5, the SSE is still dropping, but the speed of the dropping is not that significant. So, well, if I don't know the ground truth that there are a total of the 5 species, and then well, the ground truth says there are a total of 4 species, but if I don't have that, probably I'm gonna use 5 as the number of the clusters. Okay, so go ahead and pause the video here, and I'm about to show you my answer key, but I highly recommend you to code this by yourself first. Okay, so I'm gonna just pause a little bit. Okay, so this is my answer. This part, this is Euclidean distance, and I'm reusing the code from the lecture 21. And after that, I want to do a standard. I want to just try one of them, and with the k as 4, so I create the standard scalar and the k-means. And after that, for each of the sample, after clustering them into a total of 4 clusters, I can get the total SSE. So it is 100 something. And after that, well, I did a k-means SSE. And here, well, I just used the length of the dataset. So remember the last time when you see this function in the lecture 21, there is a divided by 2. But in this case, I don't have to do that, because if you want to check the dataset, so this dataset is a this is a nested list. So that is a Python nested list. So this is not a NumPy list. So if I want to count how many samples are there from the top level, and then I don't have to divide it by 2, do a divided by 2 here. Okay, and after that I do another iteration, and then for each of the value between 1 and 40, and I set that to be the I, and then using that I call the k means SSE, and then I want to do this kind of the plot. Okay, so this is the plot, and then I also added the labels for the X and Y, and then for the title of the plot. So as I said, if I don't know the ground truth, I don't know there are a total of 4 species, well, my guess after seeing this eyeball plot, probably I'm gonna pick 5 as a k value. Okay, so that's it for today's lecture, and I will see you guys tomorrow. Bye.